previous task, we learned about the definition of logarithms and how to use this to rewrite logarithms as exponential equations and vice versa. This understanding of logarithms can also help us solve simple logarithmic equations. Remember that the definition of a logarithm is, for all positive numbers a, where a is not equal to 1, and all positive numbers x, y equals log base a of x means the same as x equals a raised to the y. In order to solve a logarithmic equation, we need to find y. Until we are more familiar with logarithms, we may need to rewrite the logarithm as an exponential equation. Since y is the power the base is being raised to in order to get x, we can ask ourselves the following question. A to what power would equal x? For example, if I have the logarithm log base 2 of 16, I would ask, 2 to what power equals 16? Since I know that 2 to the power of 4 equals 16, then the answer to this logarithm is 4. That is, log base 2 of 16 equals 4. In the task you did today in class, following off a log, you created and examined the graphs of various logarithmic functions. You also discovered how changing the equation of a logarithmic function will transform the graph. In this section of your assignment, you will be interpreting the graphs of several logarithmic functions, as well as using the graph to find the equation. When identifying information about the graph, it is important to remember function notation. For example, answer the questions concerning the following graph. What is the value of x when f of x equals 1? What is the value of f of x when x equals 16? And what is the equation of this graph? Remember that x is the input of the function and f of x is the output. Since the input lies on the x-axis and the output lies on the y-axis, we can use this to help us read the graph and determine the desired values. To find the value of x when f of x equals 1, we can draw a horizontal line at 1. Similarly, to find the value of f of x when x equals 16, we can draw a vertical line at 16. Based on the graph and the lines we drew, we know that x equals 4 when f of x equals 1, and f of x equals 2 when x equals 16. Now we need to find the equation of the graph. The points we found will help us. We know that our equation is f of x equals log base b of x for some b, so we just need to determine what b is. From our answer to the first two questions, we know that f of x equals log base b of 4 and is equal to 1, and f of x equals log base b of 16 is equal to 2. If we rewrite these as exponential equations, then we have b to the 1 equals 4, and b squared equals 16. Therefore, b equals 4. So, the equation of the graph is f of x equals log base 4 of x. For problems 9 through 10, you will need to find the equations of logarithmic functions that have been shifted either vertically or horizontally. You are given both the graph and the table to help you. As you work on these problems, it may be helpful to look back at the work you did today in class. Remember what you noticed about logarithmic functions that had not been shifted, such as those found in number 1 in today's task. They all had a point at 1, 0, and they all had a vertical asymptote at x equals 0. Use this information to help you determine how the graphs in your assignment have been shifted. Where is the vertical asymptote? If it is not at x equals 0, then the graph has been shifted horizontally. If the asymptote is at x equals 0, but you don't have a point at 1, 0, then the graph has been vertically shifted. Paying attention to the table will also help you see how the graph has been shifted. Also, remember that transformations to logarithms show up in the equation similar to how transformations to quadratics do. Y equals log base b of x minus h plus k, where h is the horizontal shift and k is the vertical shift. You will also need to determine the base of the logarithm. It may be easier to first determine the horizontal or vertical shift and then find the base. This way, You can test out different bases in your equation to see what actually works. Use the numbers in the table to help you decide if your equation is correct or not. If you plug in an x value from the table, but don't get the corresponding y value, your equation may need a different base, or you may have the wrong transformation. Previously, you have learned about properties of exponents and exponent rules. In this section of your assignment, you will be using these rules and properties to help you rewrite and simplify expressions. Here is a reminder of some of the properties and rules of exponents that you have learned. A raised to the power of 0 equals 1, a to the negative b equals 1 over a to the b, and 1 over a to the negative b equals a to the b. A to the m raised to the n is equal to a to the mn. ab raised to the power of m is equal to a to the m times b to the m. And a to the m times a to the n is equal to a to the m plus n. For example, simplify each expression. Answers should have only positive exponents. T to the 4 raised to the negative 2. First, we will use the power to a power rule, which is a to the m to the n is equal to a to the m times n. Then we will eliminate the negative exponent. T to the 4 to the negative 2 equals t to the negative 8, or 1 over t to the 8. 3wx squared y cubed all squared. Each element inside of the parentheses needs to be squared, since a times b to the m is equal to a to the m times b to the m. So, 3wx squared y cubed all squared equals 3 squared w squared x to the 4th y to the 6th, or simplified, 9 times w squared times x to the 4th times y to the 6th.